We're going to take our mole to mole conversions one step further by turning moles into grams. So the question says, calculate the grams of NH3 produced from 8.923 moles of N2. 8.923 moles of N2 was my given, and grams of NH3 is what I'm trying to find. Just to refresh our balanced equation, it was N2 plus H2 yields NH3. And we had a 1, a 3, and a 2 for our coefficients. So a hint, anytime you see the word grams attached to a compound, you need to find the molar mass of that compound. So nitrogen has a mass of 14. There is 1 nitrogen in that compound for a total mass of 14. Hydrogen has a mass of 1. There are 3 hydrogen for a mass of 3. I get a molar mass of 17 grams per mole of NH3. So the first step in any conversion is to write down our given with the appropriate units. I was given 8.923 moles of N2. Now, because my given has a unit of moles, my next step needs to cancel out that moles. So this is a mole-to-mole conversion. I need moles of N2 on the bottom. And I'm asking you to find grams of NH3. So we need to first turn this into moles of NH3. This is where I write my mole ratio. There are 2 NH3 for every 1 mole of N2. If you stop the problem here, you would have a mole-to-mole conversion. But my question wants us to go one step further and turn that into grams of NH3. So to turn moles into grams, 1 mole of NH3 has a molar mass of 17 grams. At this point, you would multiply across the top and divide by the bottom. So 8.923 times 2 times 17 grams per mole. And I get a final answer of 303.4 grams of NH3. Just to kind of sum up where our numbers came from, 8.923, that was given to me in the problem. The 2 and the 1, this is my mole ratio. Those numbers come from the coefficients in my balanced equation. And then 17 is my molar mass of NH3. So the next problem asks us to calculate the grams of CO2 created from 6.332 moles of H2O. Let's go back to our balanced equation from earlier in the notes where we had 1C3H8 plus 5O2 yields 3 CO2 and 1 H2O. Now this question would be better worded if it said, calculate the grams of CO2 created when 6.332 moles of water were also created, but that's just semantics. So let's go ahead and fill in our given, which was 6.332 moles of H2O. And I'm asking you to find grams of CO2. We know that we're going to have to find the molar mass of CO2 because that has the word grams attached to it. So carbon has a mass of 12. There's 1 of them. Oxygen has a mass of 16. There are 2 of them. 12 plus 32. I get a molar mass of 44 grams per mole of CO2. We're going to start by writing down our given, 6.332 moles of H2O. I need to go from moles of H2O to moles of carbon dioxide first using the mole ratio. So there are 4 moles of H2O created for every 3 moles of CO2 that are created. If you stopped right here, you'd have a mole-to-mole conversion, but we need to go one step further and find grams of CO2, so we need our molar mass. There are 44 grams of CO2 in 1 mole of CO2. To solve, we multiply across the top, 6.332 times 3 times 44, and then we divide by the bottom, divided by 4, and I get a final answer of 208.956, so I'll round to 0.96 grams of CO2. So why don't you go ahead and try to solve this next problem on your own, balance the reaction, identify the type of reaction that you're looking at, and then solve how many grams of NiNO3 are created when 7.912 moles of AgNO3 are used in the reaction. So if you went ahead and solved that, you would have gotten your coefficients as a 3, 1, 1, and a 3. This is a single replacement reaction. And if I have 7.912 moles of silver nitrate, I would ultimately create 645.4 grams of nickel nitrate.